Hello, algebra students. Mr. B here again. Today we're going to graph polynomial functions. And we're going to be handed those polynomial functions on a silver platter. They're already factored, so we know what the zeros are. If you know what a zero is for a polynomial function, it's basically a number that would make the function zero. You can see that if x were -4, p of x would be 0. If x were 1, you'd get 0. If x were 3, you'd get 0. All right. As far as graphing goes, though, let's start with the end behavior of the graph. You know, what happens when x gets really, really negative or really, really positive? So, end behavior. We know that the end behavior is related to the first term in the polynomial. And we don't have the multiplied out polynomial, but we could sort of imagine what the first term would be. It's going to be the product of all the first terms of the binomials here. So x times x times x, that gives x cubed. And they all have a coefficient of 1, so it's just a 1x cubed. And then there'd be a plus or minus, and then a bunch of other terms to the right that we don't really care about. They're not related to the end behavior. So the end behavior is associated with x cubed, positive x cubed. And we know that that would go up to the right and down to the left. So that's what our final graph should do. Way out at negative infinity and positive infinity, it should look like that. Okay, next, let's get the y-intercept. Y-intercept. Where does the graph cross the y-axis? Well, it's easy to find. That's when x is 0, right? And when x is 0, that's when the graph, the function value will tell you what the y-intercept is. So we put in p of, we want p of 0, x is 0. So we'll get 0 plus 4 in the first binomial, 0 minus 1 in the second one, 0 minus 3 in the next one. You can see that basically this is 4 times -1 times -3, and that is positive 12. Okay, so that's our y-intercept. What are our x-intercepts? X-intercepts. And we want to know the behavior near those intercepts as well, not just where they are, but how they behave, how the graph behaves near them. And that's related to the multiplicity of each factor here, each 0. And we can see that there's a power 1 on all these binomials. That's the multiplicity. And we'll say what that means in a second here. So x-intercepts, x equal -4. That's the 0 for the first, from the first binomial here. That has a multiplicity of 1, which means that the graph just goes through the x-axis. Graph goes through x-axis. X-axis, all right. And let's get through the others. X equals 1. Again, the multiplicity is 1, so the graph goes through just like the other one. And then the third one is positive 3. If x were 3, this would be 0. Okay. Those real zeros, meaning they're real numbers, those real zeros are the x-intercepts. Okay. Its multiplicity is 1. Okay. We have all the information we need to graph this polynomial. Let's start putting some of the details on the graph here. We know that the y-intercept is 12, and I'm going to fudge a little bit here since it's so high up. The scaling on the y-axis is going to be a little different than on the x-axis. So on the x-axis, we've got a x-intercept at -4. We have a x-intercept at 1, and then at 3. I'll put the numbers in later. And we know that it has to go up really far to the right, and it has to go down way over on the left side. and it's got to snake through these because through all the intercepts, because the graph goes through all these intercepts because we have multiplicity 1. Okay, so it must come up through this intercept, through the y-intercept, back down through the next x-intercept, and then up and off to infinity, right? Okay, let's put our numbers in here. This is -4. Put the origin on there, 0, 1, and 3. And that's it. That's how easy it is to graph this polynomial. So as a recap, we get our end behavior, the y-intercept, then we can look at the x-intercepts and their behavior based on the multiplicity. Okay. Let's go to the next one, the next example here. So end behavior. End behave. What is the first term going to be if we were to multiply this all out? That's what the end behavior is based on. So if we multiplied all the x's together, we wouldn't just get x cubed here, because notice that the first binomial is squared. That means that this 0 of 3 has a multiplicity of 2. So this is like x squared here. And the next one's x to the first, and the next one's x cubed. So adding all the powers, we're going to get 2 plus 1 plus 3, that's 6. X to the 6th is going to be our first term, and then there's all these other terms that we don't care about. And again, the coefficients are 1, so it's just a 1 here. 1x to the 6th. So x to the 6th is positive. What does that look like? Well, that's an even power of x, so it goes up to the left and up to the right. That's the end behavior. What is the y-intercept? Again, that's where x equals 0, and we have to put in 0. So if we put in 0 for x everywhere, can you see that we're going to get -3 squared times -5 times 2 cubed. And what is that? -3 squared is 9 times -5, and then 2 cubed is 8. So what is that? That's 40 times 9. That's 360, and it's negative because of the negative. There's one negative. Hope I multiplied that right in my head. 40 times 9. Yeah, 360. Okay, now for the x-intercepts and their behavior. So let's start with the left one. X equals 3. Remember, it's always the opposite. If it's x minus something, the 0 is positive. Where I was talking about like an x minus c, where c is the 0. So it's 3, and the multiplicity is 2, and we know that when the multiplicity is 2, that the graph just touches the x-axis. Kind of like a parabola touches, the x squared touches the x-axis. So graph just touches the x-axis. All right, and then the next 0 is 5. That's an intercept too. M is 1. Graph goes through. Graph goes through the x-axis. And then the next one is x equal -2. And that has a multiplicity of 3. And when it's 3, then the graph goes through, but it flattens a little bit. Graph goes through, and it flattens. What's the deal? If the multiplicity is even, like 2 or 4 or 6, whatever, the graph just touches. If it's odd, it goes through. And if it's, they say 2 or higher, it flattens. Like, you think of x squared, that flattens as it touches the x-axis, right? Well, x cubed also flattens, but it goes through. And we'll see what that looks like in a second here. We're ready to graph. We're ready to graph here. So let's get all the details in front of us here. All right. Again, I'm going to have to do some severe scaling differences on the y versus the x-axis because the y-intercept was negative 360. That's way down here. All right, and then our x-intercepts are at 3. 1, 2, 3, and 5, 4, 5, and negative 2. That's there. And what do we say the end behavior was? It has to go up on the right. It's got to go up on the left. And let's start going from left to right. So we must be coming down to this first negative 2 intercept. And that says it flattens, it goes through, and it flattens. So it must come down and touch and then kind of go like that. You see how it's flattening out a little bit as it goes through. Okay, then it's got to go through the y-intercept. And then what does it do at the 3? It has to just touch at the 3 intercept. So I'm going to come back up and kind of sort of like a, locally it sort of looks like a parabola just touching at positive 3. All right, and then it's got to turn around somewhere. We haven't talked about turning points. I don't think we should, because you can see what they are as we do this. It goes through at 5. It goes straight through, so it's going to turn around and go up. So there it is. You can see there's like 3 turning points. 1, 2, 3. All right. Next one. Next one. That was easy, wasn't it? Next one. Okay. End behavior. End behavior. So this one's a little different. I've thrown a twist here. I've got a negative 2 sitting out in front. I think you remember maybe the P of x standard, what am I saying, factoring has a sub n sitting out there, and then you have the x minus c1 and the x minus c2, blah, blah, blah. Okay, so this one has that coefficient sitting out in front. And what is the x power that we're going to have? Again, it's adding up the powers. So this first binomial has power 1, this has power 1. So it's like x times x squared, because the last one has a power 2. So that's x to the 4th. And sitting in front of that is the negative 2. So the end behavior is negative 2x to the 4th. It's negative, and it's even, so it goes down to the left and down to the right. It's basically a reflection of x to the 4th. You know, x to the 4th itself is, it sort of looks like a parabola. It isn't, but, and then if you have the negative out front, it's going to flip it down. And the 2 is doing some stretching, but we don't need to know all that. All we want to know is it goes down to the left and down to the right. Okay, and then the y-intercept. Y-intercept is, again, when x is 0, we'll get negative 2 out in front there, and then we get a 5, and then a negative 1, and a negative 4 squared. Putting 0 in, it doesn't do anything. We just left with these numbers in the binomial. Okay, so what do we get here? That's 10 times 16. That's 160. And what's the sign? The thing that's getting squared, that's positive. And then there's 2 negatives after that. So it's going to be positive 160. All right, and then our x-intercepts, we get, let's see, starting from the left up there, -5. That has m equal 1. That means it goes through. I'll use the abbreviation for through. And then x equal +1. That's also m equal 1, multiplicity 1. The graph goes through. And then x equal 4. There the multiplicity is 2. And that means that the graph just touches, right? Graph just touches the x-axis. All right, let's graph this. Let's graph this thing. All right, so here's x, here's y. What was our y-intercept? It was really high up there, but again, I'm going to be scaling a lot. This is our 160 there. The behavior, we know we're going to go down to the right and down to the left. We'll think about that in a minute. Let's put on our x-intercept. So -5, 1, 2, 3, 4, 5, and 1, x equal 1, and we have another one at 4. 1, 2, 3, 4, right there. All right, let's start at the left. As we come up to the -5 one, it says go through. So we come up there, and there's no other x-intercepts before the y-intercept, so we're going to have to come through the y-intercept somehow. And what does it do at 1? Well, it goes through again, so that's okay. We come down through the 160. Oh, and this is kind of cool, right? It must turn around because it's just going to touch at 4, and that means it can go back down just like we want the end behavior. You know, basically, if things don't go according to the way you planned it, if something doesn't match up, you know there's a mistake somewhere, right? So if somehow I went up through here and thought, oh, it goes through at 4, but the end behavior said it went down, I know there'd be something wrong. But anyway, all right, that's it, folks. We'll see you at the next video. I realize I haven't written down a few things here. I better put my -5 and a 1 and a 4. That's a little better. Okay, now it's time to say goodbye. We'll see you at the next video. Bye.